Before mathematics proves anything, it asks a very strict question. Can this sentence even be true or false? If the answer is no, mathematics refuses to work with it. In this video, we will uncover the hidden rule that decides which sentences are allowed inside mathematics and which are not. The first thing we have to know about is a statement. A statement, also called a proposition, is a sentence that is either true or false, not both, not neither, exactly one of the two. It means a sentence qualifies as a statement when it can be evaluated as either true or false. Let us examine a few examples to strengthen our understanding. First one is 2 plus 3 is equal to 5. What do you think about this? We can easily tell it is a true sentence. That means it is a statement. The next is 7 is a prime number. Again, this is a true sentence. That means it is also a statement. The next is 12 is divisible by 5. We know it is a false sentence. But is it a statement? Yes, because any sentence which can be evaluated as either true or false is a statement. It does not say that only true sentences are included. The next is x plus 1 equals 4. What do you think? Is it a statement or not? This is not a statement because the truth or falsity of x plus 1 equals 4 depends on the value of x and we do not know what x is. For some values of x, it is true, whereas for other values, it is false. The next is close the door. Not a statement, it is a command, not something that can be true or false. The next is what time is it? Not a statement, it is a question, again not something that can be true or false. Mathematics only works with the things for which truth has a meaning. So the first job of a mathematician is to identify what is a statement and what is not. Now the question is, why are statements so important? In mathematics, nothing exists without statements. Every theorem you study is a statement. Every lemma, every definition, every proof, each one is built out of statements. A proof is simply a structured way of showing that a statement must be true. If something is not a statement, it cannot be proved, disproved, or even discussed logically. Mathematics does not argue with opinions or guesses. It only works with sentences whose truth can be decided. Now let us discuss the most common types of statements. The first is universal statements. A universal statement says something about every element in a set. For example, every natural number is either even or odd. This tells you something about all natural numbers at once. Another simple example is for every real number x, x square is non-negative. When you hear for every, for all, or for any, you are looking at a universal statement. The next is conditional statements. A conditional statement says that if one thing is true, then some other thing also has to be true. It has the form if P then Q. For example, if a number is divisible by 6, then it is divisible by 3. Here you are not saying every number is divisible by 6. You are only saying that whenever that happens, divisibility by 3 must follow. The next is existential statements. An existential statement says that at least one element exists that makes the property true. It has a form there exists an x such that px, where px is the property. For example, there exists a prime number greater than 100. Another example is there exists a real number whose square is 2. Now let us wrap it up. A mathematical statement is a sentence that is either true or false. If the truth or falsity cannot be determined, then it is not a mathematical statement. The most common types are universal, existential, conditional. These forms are the foundation of proofs and modern logic. In the next video, we will learn the language of sets, so stay tuned.